Alright, so first things first, let's look at what we have coming up. This week, today, we're going to do an elevator ride simulation. Now, have you ever been in an elevator before? For the most part, yeah. By the way, I didn't tell my other classes this, but when I was a little bit younger than you, I was going in 8th grade. We moved to a new city. And we happened to move into the city the same month that the very first escalator ever went in the city. And it was such a big deal, it was on the news every night for like 2 weeks of them reporting from the mall, and JCPenney has an escalator now! And I kid you not when I say, I went to the mall right around that time. It was, it'd still been open for a while. It was like a month later. And we were in JCPenney's, and I see a kid who was your age, some high school kid with a girl on each arm, and he goes, "Let's ride it again!" And he was serious. And they were just riding the escalator up and down, up and down. Always makes me laugh to this day. Alright, yours though is on an elevator. And if you've been in an elevator before, you know the sensation of what it feels like as you're going up and down. What we're going to do today is we're going to analyze that. We're going to put a little bit of math to it. Mostly physics concepts, though. The reason I really wanted to pull up the overview, though, is what do we have coming up next class?
A practice test.
Practice test. Which means on, what would that be? I think Monday for you next week, it is going to be your test on forces. So, just put that in your planner. Make a mental note. You do have a test coming up. It will be open notes. I recommend making a cheat sheet as well. But if you have any questions, next class is going to be the primary time to ask them, okay? Because it's just going to be, for those of you who weren't with me for the last test, the test is all a longer version of my real test with different numbers, different questions slightly. And it's a great time to go through and make a practice study guide for what's going to be on the test. And then you cut out whatever questions, or I cut out questions rather, and you go through, you've basically seen the test in advance, just a longer version. Okay? Any questions on all that? Alright, well let's get into today's work then. Head to the modules, and head to the assignment in particular. Okay, so, with the elevator ride simulation, first of all, this guy has something none of us ever have in an elevator. He put a lazy boy in his. We never get that. But he's going to start, he's going to have a status up here. He's going to be at rest on the first floor. We can see what floor he's on as he travels. And he's going to think, and you'll be able to see his thoughts, about what he's experiencing. Does he feel heavier than normal? Does he feel lighter than normal? Does he just feel normal weight? And on the side, of course, here, our free body diagram. Now, as he moves, I want you to get a sense of how fast this is going to go. We see he's accelerating upward. He feels heavier. Those floors are changing pretty fast. Then he's going at a constant speed. Tells you how he feels. We can see what the free body diagram looks like. And then he starts slowing down, because you got to slow down as you're reaching your floor. And it describes pretty quickly how it's going, because elevators go fast enough. You can repeat this ride as many times as you want to, and believe you me, you're going to want to, because you're not going to be able to get all the information you need in the first pass, because it goes too fast. So, when I talk about the information you need, you're going to fill in this chart and this chart, once going from the first floor to the 20th, and then once going down, to describe what it is that, what floors is he speeding up on, constant speed, slowing down, his acceleration, they give that to you right in the problem. Is he accelerating up or down? Does he feel heavier, normal, or light? And using your free body diagram, which one's bigger? Do a greater than or less than signal, and then you'll be answering some questions. It's actually going to be a pretty easy thing today. But let's still go ahead and read about this. So, Charles, would you pick somebody to read?
Conrad.
Alright, Conrad, read as far as you want, and then you can pick somebody new whenever you're ready to switch.
Background. Imagine being in an elevator and riding from the first floor to the 20th floor. You start from rest, speed up, maybe a floor or two, until you get up to cruising speed. Then you cruise for several floors until you are nearing your destination. As you near your destination, you slow down from cruising speed to a final stopping position, i.e. a 0 speed. What would you feel during this time, and why would you feel it? Who else is here today? I choose Brody.
Brody's is still connecting to audio, so it means he hasn't accepted, finished connecting yet.
I choose Adam.
Alright, where are we at?
Purpose.
Purpose.
Alright.
Everybody pay attention, because you don't know if Adam's going to choose you or not after he's done.
The purpose of this activity is to relate physics principles, Newton's second law, and free body diagrams to the often experienced motion of slowing down, moving at a constant speed, and speeding up on an elevator ride. To do: ride the elevator from the first floor to the 20th or the 10th floor. Ride it back down. Repeat several times while making observations of the acceleration values, the free body diagrams, and the rider sensations. Record observations in the data section below. Repeat the process for a ride from the 20th to the first floor.
Alright. Any questions about that part of things? Filling in these tables. Alright, so here's how we're going to do it. I'm going to put you in groups of